A convection microwave is a combination of a standard microwave oven and a convection oven which can heat the outside of food to higher temperatures than a conventional microwave. Food cooked in the convection microwave can be cooked quickly, as in an ordinary microwave oven, yet come out browned or crisped as in a convection oven. Although some microwaves contain electric browning baking elements, a true convection microwave has a high-velocity forced air fan to circulate the hot air uniformly. However, most cakes cannot be baked in a microwave oven, only those without an open grain structure, such as brownies. Convection microwave ovens were initially considered to be high-end kitchen appliances. Over time their prices dropped, and they can be bought for around the same price as a conventional oven. However, some models do require more space than a standard microwave, because of the larger cooking area inside. There are some important features that you should look for when choosing a convection microwave. This is particularly important given the hybrid nature of the design, which must encompass both the elements of a microwave as well as a convection oven, all in one unit. Capacity. The size of convection microwaves can vary from a small 4-slice unit to a larger 6-slice one. While the required capacity will depend on your requirements, most people prefer at least a 1-foot interior capacity. Construction quality. Most units on the market today are durable and built with good quality materials. Brands such as Oster and Cuisinart are known for producing high-quality convection microwaves. Dimensions. Convection microwaves tend to be larger in size than traditional microwaves or convection ovens, so it is important to check carefully the unit will fit in your available countertop space. It is also critical to check the instruction manual carefully to ensure there is sufficient space around the convection microwave to prevent it overheating. Cooking power. To ensure your food will cook quickly and evenly, the convection microwave should have a power rating of at least 950 watts. Design. The design aesthetic should be something suitable to match your kitchen decor and personal preferences. Brands such as Samsung are known for offering modern, stylish designs with reflective glass doors and brushed steel exteriors, while other brands such as Panasonic offer a more traditional style of convection microwave.
This microwave oven is a truly remarkable feat of engineering. The rapid heating that makes microwaves popular is made possible by power provided from this vacuum tube. Now, if you picture a vacuum tube at all, it's likely in a radio like this. Inevitably, tiny transistors and microchips replace clunky vacuum tubes, but it's too soon to relegate them to the museum. Microchips can't easily replace tubes for producing power, for example, in heating food. Now, a microwave contains 3 main components. A vacuum tube called a magnetron. It generates the energy that heats food. A waveguide hidden in the wall to direct that energy to the food, and a chamber to hold the food and safely contain the microwave radiation. In principle, a microwave oven heats no differently than any other type of heat transfer. At a molecular level, heat is a transfer of energy that results in increased motion of the molecules in a substance. Since we aren't quantum-sized, we observe this increase in motion as a rise in temperature. In a traditional oven or stove, we heat food by placing a pan on a burner, or in the oven where the walls radiate heat, which cooks the outside of the food. The insides cook when heat transfers from the surface of the food to its interior. In contrast, energy from the magnetron penetrates into the food, which means the whole mass of the food can be cooked simultaneously. How does it do this? Well, our food is filled with water, which is positively charged at one end and negative at the other. To give these molecules more energy, we expose it to electromagnetic waves that emanate from the tube. By definition, the waves have the electrical and magnetic fields that change direction rapidly. For this oven, the direction of the fields change 2.45 billion times per second. Water will try to align with the radiation's electric field. The changing field rocks the water molecules back and forth rapidly, and molecular friction from this creates heat as the motion disrupts the hydrogen bonds between neighboring water molecules. Now, you can get an idea of the wavelength of the energy emitted from the magnetron using cheese. Now, you can see on here sections where the cheese is completely melted and other sections where it's completely unheated. The oven's metal walls only reflect waves of a length that fits inside the oven. This standing wave causes hot and cold spots inside the oven. The three-dimensional pattern of waves is difficult to predict, but the principle can be seen by looking at the waves in a single dimension. The peaks and valleys in the wave represent the greatest energy of the wave. Well, the nodes here correspond to the cold spots inside the chamber. If I measure the distance between melted cheese spots, I find about 2.5 inches. That would be half the wavelength, the distance between nodes, and is pretty close to the actual wavelength of microwave radiation used. Using that wavelength, I can estimate the microwave radiation's frequency. The frequency is related to the wavelength by the speed of light. I get an answer that only has a 4 or 5% error, not bad for this primitive measurement. Now, the real engineering in the microwave oven lies in creating the magnetron that generates high-powered radio waves. It's truly an amazing and revolutionary device. The vacuum tube is inside here. These are cooling fins, thin pieces of metal that dissipate the heat as the magnetron operates. The key parts are these two magnets and the vacuum tube. Now, I have another one so you can see the inside. You apply a large voltage across both the inner filament and the circular copper outside. This voltage boils electrons off the center filament and they fly toward the circular copper section. The filament is made from tungsten and thorium. Tungsten because it can withstand high temperatures, and thorium because it's a good source of electrons. The magnets bend these electrons so that they swing back toward the center filament. We adjust the magnetic strength so that the now orbiting electrons just brush past the opening of these cavities. Like blowing over a half-filled pop bottle to make it whistle, this creates an oscillating wave, the microwave radiation that heats food. It's simply astonishing that these cavities can be made with high precision, low cost, and incredibly high reliability. I'm Bill Hammack, the engineer.
About 20 people a day end up in American emergency rooms from microwave oven-related injuries. A few from microwave popcorn steam, overheated hair removal wax, nearly one a day from exploding eggs, but most are from overheated water. See, when you boil water on the stove, bubbles rise from the bottom, and as they burst, the excess heat is dissipated. Water heated in a microwave oven, though, may not bubble, and so can get even hotter than normal boiling temperature. Then if you sprinkle in some powder, tiny air bubbles are carried into the liquid and can expand into steam bubbles and erupt onto your hand. The FDA warns to be careful when trying to boil water in a microwave, particularly in a shiny container, or more than once, or for too long, or when not letting it cool down a bit first, or when dumping something into it. Most microwave-related burns in young children occur when the child reaches in to grab something hot. Toddlers as young as 18 months can open a microwave, so some public health advocates have recommended that instead of just warning people to let stuff cool first for a few minutes, there should be some kind of door lock that doesn't even let you open the thing for 2 minutes after it stops, which kind of undermines the whole point of quick microwave convenience. A better idea may be to just kind of child-proof the door, so you have to turn a knob while pressing a button to pop the door open. When people express concerns over microwave oven safety, though, they're probably not thinking about exploding eggs or hair wax injuries. They're concerned about the microwave radiation itself. Microwave oven manufacturers caution people not to operate the oven with the door open, but there are interlocking safety switches that should turn it off automatically when you open the door, unless you're stuck inside one. God, I couldn't even read that article. There is some leakage of microwave radiation, though, during operation. There's this famous radio telescope scanning the cosmos for extraterrestrial civilizations. Fast radio bursts were detected, a sign of extragalactic intelligence. Nope, turns out ET was a microwave in the staff cafeteria that the telescope caught when it was just at the right angle, right when someone yanked the door open. You don't need a radio telescope to see it, though. A cheap way of detecting microwave oven leakage is to just place a computer monitor next to the oven. You can see disturbances on the screen. Or just use the microwave detector you have in your pocket or purse right now. Cell phones. Look, if microwaves can leak out, then they should also be able to leak in. The microwaves are actually quite similar in size, the wavelengths, though obviously different intensity between microwave ovens and cell phones. So stick your phone in the microwave. Do not turn the microwave on, but close the door and see if you can call it. When you hear it ringing, that's confirmation that microwave-type radiation can leak in and out. And indeed, you can just directly measure the leakage during operation, though nearly all within prescribed safety limits. And once you move the detectors like a foot away from the door, the levels fall nearly to zero, even if there's like some food particle or something caught in the door seal. Now, the industry will tell you that there has never been any verified case of human injury due to exposure from radiation leakage from microwave ovens. This is from a guy at Raytheon, though, where the microwave oven was invented, after an engineer in a radar lab noticed the chocolate bar in his pocket had melted. There has been the rare case report of a malfunctioning machine that didn't turn off when the door was open and someone burned themselves, but this was after her hand was in there for like a full minute. Raytheon engineers talk about how they inadvertently exposed themselves lots of times to open active microwaves. They get a warm tummy, they feel a little transient warmth when they pass their arm in and out of the oven, but no big deal, they say. In fact, the same microwaves used in microwave ovens are the same used for medical microwave diathermy, which physical therapists use like a hot pack to treat like rotator cuff injuries. Now, making the claim that, well, if the medical profession uses it, it must be safe, isn't exactly the strongest argument, but does help to put things in perspective. When the heating of people is not deliberate, it may be desirable to limit exposure. Is that minor leakage during operation anything to worry about, though? In other words, are there non-thermal effects of microwaves? If it doesn't burn you, can it still hurt you? The Soviets thought so, irradiating everyone in the U.S. Embassy in Moscow for decades. In terms of microwave ovens, though, the only report I could find was from over 40 years ago, a case report of a woman who developed cataracts after using a leaky microwave oven. But that's all there was, just this kind of circumstantial evidence correlation. I mean, look, lots of people get cataracts, lots of people use microwaves. There has to be more than that. The only follow-up study I could find was this Turkish study, published a few decades later, but it was on rats. Now, they did end up finding some superficial eye abnormalities on the rats placed next to the microwave, but they were like right up against the door, and people don't tend to stick their faces right up to the glass while things are cooking. So even if the same thing happened to human eyes, this study might be of limited relevance, but it can't hurt to stand back from the microwave while it's on. Otherwise, microwaves should be safe, unless you drop it on your foot.